Hello, my dear students. My name is Chakradhar and I am a physics lecturer. Actually, here I am going to explain the relation between impact parameter and the angle of scattering in alpha ray scattering. If you like my video, please share it with your friends. Thank you. Here I am going to explain the alpha ray scattering. So in alpha ray scattering experiment, what the Rutherford did is, suppose this is the nucleus. Let the charge on nucleus be Q, that I'm going to write here. Q is charge on nucleus, and if the projected alpha particle in that experiment towards the center of the nucleus, okay, then here we can calculate what will be the closest distance of approach. But actually today my intention is not to calculate that closest distance. Okay, my intention is here, instead of projecting along the line passing through the center of the nucleus, I am projecting, not I, actually Rutherford suppose projected here one alpha particle towards the nucleus at some perpendicular distance. Take it as the perpendicular distance. That perpendicular distance BD. That perpendicular distance, what I have shown here, is called as impact parameter. Okay, let the charge on the alpha particle be Q. Okay, I am representing here Q is charge on alpha particle. And it is projected, suppose with a velocity V initially. V is the velocity of projection. My dear students, here you have to keep in mind that the alpha particle is coming close towards the nucleus. When it comes close to the nucleus, when it penetrates the atom, the size of atom, all of you know, that is in angstroms. That's why it is coming close to the distances of angstroms towards the nucleus. So compared to angstroms, even though you project very close to the substance, the target, okay, like in meters of distance, that distance, which is in meters, compared to angstroms, which is 10 power minus 10 meters, compared to the atomic separation, sorry, the size of the atom, whatever from outside you are projecting in meters of distance is nearly 10 power 10 times. So compared to that size of atom from where you are projecting even close to the target is considered as infinite distance. That's why here initially you can consider, even though it is projected from a closure distance of the target, whatever you are taking there, like gold foil, that distance is considered as infinite distance. That's why you can take, initially it is projected from infinite distance. Actually, it is not from infinite distance. That is just in meters. I already told there, compared to the size of atom, those distances are considered as infinite distances. From there, you are projecting. Since it is initially projected from infinite distance, unless and until it comes close to the nucleus, means before penetrating the atom, very close to the nucleus, okay, those distances are considered as large distances. That's why usually until it come very close to the nucleus, you won't find any force of attraction or repulsion. Okay, in this case it is repulsion. Why? Because alpha particle is positively charged, nucleus is also positively charged. So when it tries to penetrate the atom, at that distance you can find some force of repulsion. From there, actually that velocity will be changed, means direction and magnitude. So from here, I'm mentioning that change of its direction with a dotted line like this, like a curve. Okay. Suppose it crosses the atomic radius, like suppose comes out of that atom. Again, it comes to a distance nearly more than angstroms. Okay, those distances again you can consider as infinite distance compared to the angstrom, this 10 power minus 10 meters. So again, from there, it may travel almost tangential to the line. So it may go like this. So here, if you see, this is the initial direction of projection. And finally, it went like this. So tangent, if I take there, you can find through how much angle finally it is deviated. That final deviation is represented, suppose with the letter phi. That phi I'm taking here as angle of scattering. Okay. So in this case, what I'm going to find out, what will be the relation between this angle of scattering and B? Okay. Here I'm considering that particularly from here to there we are finding out a large force is acting on the alpha particle. So all those distances are considered as infinite distances compared to the atomic separations. Okay. Oh, so here, suppose I'm considering the velocity is changing from here to there, almost in that region. Okay. What will be the final change in this linear momentum? Okay. Point to point, actually, in this region, velocity is changing, magnitude and direction. That's why if you want to find out what will be the change in linear momentum, delta P, which is change in linear momentum, you have to take the integration of dp. Okay, that integration of dp is nothing but p in the limits of p final to p initial. Finally, it is coming out with the same velocity of projection. Initially, the velocity of projection is v. Okay, so here, this one I'm taking it as p final minus p initial, that both are not in the same direction. That's why here we can take it as m into v final, that is v bar, minus m into v initial v bar. Okay, both are in two different directions, but their magnitudes, initial and final, are same. Okay, so here, this one, what I am taking, don't take it as zero, Nana. Why? Because their directions are not same. Okay, so here the change in linear momentum, better instead of writing like this, I write it as this is the initial linear momentum direction I'm mentioning here. And this is the final linear momentum. I mention it there like this. Okay, sorry. I mention like this here. Final one. Okay. Angle between them is given as phi. This is mv and it is mv coming out before penetrating, after penetrating, comes out with the same velocity, same magnitude of velocity. Okay. In this case, here, what he is saying, change in linear momentum means, we have to consider by changing, this is P final and this is P initial. P final minus P initial means we have to change the direction of initial one to get minus. So here I am taking it is P final as usual. And here I am taking it as P initial like this. Okay. If I take the angle between them as, since it is phi, other side angle, this is 180 minus phi. Then this is P final, and it is actually minus P initial bar, but its magnitude is mv. Okay, these are the magnitudes. So according to parallelogram law of vectors, the addition of these two vectors means P final plus minus P initial is equals to magnitude is equals to root of all of that is mv whole square plus mv whole square. Both the magnitudes are equal here also. Plus I will write here 2 mv into mv into cos 180 minus 5. This is what I got here under root, which is nothing but if you take mv square common there in the root, I will get mv whole square into here 2 plus 2 cos 180 minus 5 is minus cos 5. So I put here minus 2 cos 5. Again, if I take 2 common, then I will get 2 mv square into 1 minus cos 5. 1 minus cos 5, all of you know. Okay, that is 2 cos square 5 by 2. Sorry, 2 sine square 5 by 2. Okay, so here this is root of 2 mv square into 2 sine square 5 by 2. So altogether I am getting the change in linear momentum delta p is equals to, finally after integrating, I will get this is 2 mv sine 5 by 2. Okay. And particularly from here to there, the force, what I said, force of repulsion between them will be considerable. Okay. So in that range, if you see force direction continuously change, Nana. So continuously change means actually thus delta P using the formula. Delta P is equals to actually F into T, what we have to write. According to the formula, F is equals to delta P by delta T. Okay. Since force, direction and magnitude continuously change. Why? Because separation continuously change here and direction of force also continuously change, repulsive force between them. That's why here again I have to go to integration. So delta P here I write integral F dt. Okay. So here, since these two magnitudes are equal, the delta P, what you got 2 mv sine 5 by 2, exactly bisects the angle, like this, you will get perfectly like this, bisecting the angle. This is the resultant vector. Okay, that you will get here like this. Suppose coming from here like this, make up like this. Sorry. Exactly bisecting. Consider the angles on both sides are equal. Okay. Exactly bisects means you observe from here to there, the total angle here is 180 minus 5. I have shown there in the diagram. Okay. So here that 180 minus 5, the angle on one side is half of that 180 minus 5 since it bisects. So this will be 180 minus 5 by 2. And that also will be 180 minus 5 by 2. Okay, from here you can say. So this is what I said delta P. Finally, the resultant change in linear momentum. Okay, finally, right? So this is the final change in linear momentum means, why don't you fix it as one reference line? Why? Because the force here changes. Suppose if I show like this, the direction continuously change from point to point like this. And the distance also changes. That's why here the force continuously change. That too angle made continuously change. That's why better we take this as a reference line, and at one particular instant, at a distance r, at one particular instant, I try to measure that angle, okay, with delta p by taking it as a reference line. So that here I can write the limits of the angle made by the, suppose if I say it is the force now, at an instant, repulsive force. So that it is the angle made with delta p. Suppose it is theta. The theta limits while integrating, I can write like from other side, means minus 180 minus pi by 2 to plus 180 minus pi by 2. I can show the limits here very easily. That's why I take delta p as the reference line. Okay. So here, after seeing my explanation, then here I'm going to the next diagram in the next page. Okay. I think you understood here what I explained. So here in the next page, what I'm going to do, this is the reference line for me, delta p. And at an instant, I'm finding out, suppose the alpha particle is here, I take it is the force. Okay, suppose better I take to measure the angle, I take like this at an instant. Okay, means this is the position of nucleus, and this is the position of alpha particle at that instant. Take it as alpha particle at that instant. This is small one. Okay, so it is the alpha particle and it is the nucleus, whereas the separation is some unknown r. Okay, and here at that instant, suppose tangentially, if you take the path like this here, tangentially you will get some velocity here. This is the direction of velocity. Okay, I don't know the angle between the velocity and r nano. Okay, here I can say one thing. This separation will be minimum when the velocity component comes perpendicular to each other, perpendicular to the separation. That you know in your first year while explaining the relative velocity concept. There, the distance between two boats, two ships, while rowing in two different directions, while calculating the minimum separation between the two boats, what we say, the relative velocity between them. Here, relative velocity means nucleus is at rest, Nana. That's why whatever the velocity of alpha particle is the relative velocity with respect to the nucleus. Okay, that's why the velocity of alpha particle, I can call it as relative velocity. The relative velocity of the two ships in first year, a relative motion concept, okay, is suppose perpendicular to the separation between the two ships, then that separation is called as minimum separation, what we learned in first year. So if I take it as the perpendicular velocity to the separation, then I can call it the R, what I took here. I can call this R as minimum distance, minimum separation between the two alpha particle and nucleus. Okay, just reminding. Okay, just keep this point in buffer, Nana. Later we will come to this conclusion. Okay, while calculating the relation between the impact parameter and minimum separation. At that instant, we try to collect. Okay, so here at this instant, what I'm saying, delta P, already I calculated, Nana. Left hand integration already over. I'm coming to right hand side, the integration of right hand side that already I calculated. Better I highlight this one. This is delta P. Left hand side is over. Now I'm trying to calculate what will be the right hand side. Okay, at some separation, may or may not be this one minimum separation. Okay, at that instant, it is the force of repulsion, direction of force of repulsion, and this is the reference what I took, delta P, and the angle between them I am taking it as theta. Okay, so here while substituting, if you want to take the delta P here, I have to take the component along that line. Okay, the component along that line means if you resolve that f in the direction of delta P, reference line direction. Then in that direction, I am getting here, this is f cos theta. So finally, if you want to calculate delta P, I have to take the component of here f cos theta in place of f, okay, which is influencing the linear momentum. Other component will come perpendicular to this delta P, that won't influence delta P, you know, in the laws of motion chapter. So this is f cos theta into dt, I write here, where f I am going to substitute like the formula 1 by 4 pi epsilon naught, like q into q by some r square into cos theta into dt. All are different terms. Okay, you can't integrate either theta or r. These two are variables. The rest of the things are constant with respect to time. That's why I require one more equation here to simplify this integration. So I'm taking the help of another one. In the meanwhile, I take it as equation 1. Okay. And this one, what I took, what I integrated, this one I represent like the equation capital 1. Okay. I take this pink color box. So here at that instant, what I do, since this is the force of repulsion between the molecules, between the, atom and the alpha particle and nucleus, here you can do one thing. Okay. According to the law of conservation of angular momentum, okay, since the direction is changing here, according to the law of conservation of angular momentum, what can I do? The angular momentum at the initial position should be equal to the angular momentum at this position. Okay. So initial angular momentum means r cross p. If I take L initial, I write it as by using r cross p, that is p into perpendicular distance. What I'm writing the magnitude. Linear momentum is mv into perpendicular distance is b from the line here. Okay. And when you come to here, I say from the nucleus, L at an instant is equal to, suppose here the velocity is v1, I take it as m v1 into, actually I have to write, if these two are not perpendicular to each other, I have to write sine of something component or or either sine theta or cos theta, whichever coming in this direction, which is perpendicular to v. Okay, so mv1 into here, what I write, simply the perpendicular distance. Since I am not considering the v1 which is coming perpendicular to the separation, means I am not considering this as r minimum, I can't say it as mv1 into r. Okay, so here if I take v1 which is perpendicular to r, then I can write this one as, or I can write it as mv1 into, this is r minimum if I consider v1 coming perpendicular to the separation. Okay, or at an instant I can take it as I omega. I omega means you can consider the alpha particle as point mass, and you can write it as m into here from the center, the distance is r square, mr square, okay, into omega. Okay, at that omega, here the angle changes now. So I write it as omega as mr square into d theta by dt. Okay, I write. Why? Because when r changes, theta changes. So here the omega is corresponding to change in that theta. Okay, so mr square into d theta by dt I can use. I think this is better. Why? Because r square and dt in a single shot I can eliminate. So if I use the law of conservation of angular momentum, so next here I write according to law of conservation of angular momentum. I can write here mv into b is equals to this one. Later I try to use nano, and this is not useful. Why? Because by taking v1 and r and again those two are making some angle, it is very complicated. So I'm not going to this one. And better here, I'm going to use mr square into d theta by dt, particularly to eliminate r square and dt here, and incorporate d theta there, which is here to is very easy to integrate. That's why I'm going to the third one here, that is m r square into d theta by dt. So to eliminate their dt by r square after cancelling, I will write this one as dt by r square is equals to, I will write d theta by vb. dt by r square after cancelling d theta by vb. Yes, take it as second equation and substitute 2 in 1. Then you will get delta p is equals to 1 by 4 pi epsilon naught here, q by r square, and integral here, sorry, q r square is there inside. Actually, I have to write q into dt by r square into cos theta. Now in this formula, dt by r square, I'm going to substitute what 1 by 4 pi epsilon naught q into integral dt by r square, second one, substituting in this equation, that is d theta by vb into cos theta. Again, v and b are initial terms, initial velocity and perpendicular distance. Initial perpendicular distance, they are constants. So you can take 1 by 4 pi epsilon naught cubic and also vb out of integration q and by vb. Integral, you are getting cos theta d theta. Now you can substitute the limits, what I told previously, that theta changes from 180 minus 5 by 2 to minus 180 minus 5 by 2. Plus 2 minus 1 is clockwise, other is anti-clockwise. So here the two angles here you can substitute like 180 minus 5 by 2, other side minus, and here this is plus 180 minus 5 by 2, the two limits of theta. Cos theta integration is sine theta. So in next phase, you can write it as 1 by 4 pi epsilon naught q by vb. And here, write that is sine theta in the limits minus 180 minus 5 by 2 to plus 1 by t, sorry, plus 180 minus 5 by 2. Okay, Nana? This is the thing what we have to write, plus 180 minus 5 by 2. So substitute here. This is what actually I'm calculating, delta P is equals to, I got 1 by 4 pi epsilon naught q by vb. And here first upper limit sine 180 minus 5 by 2 minus sine minus 180 minus 5 by 2. Okay. So you will get here all together after substituting the two limits. This is equals to 1 by 4 pi epsilon naught q by vb. And here this is 180 by 2 is 90. Sine 90 minus 5 is cos 5. You will get cos 5 by 2. Sine minus theta is minus sine theta. So plus minus of minus. Again, sine 180 by 2 is 90. 90 minus 5 by 2 is cos 5 by 2. Okay, I think you can understand this step. And here you can write 1 by 4 pi epsilon naught q by vb into, you are getting 2 cos 5 by 2. This is delta p. Okay, now just check the two pink color boxes, what we highlighted. Okay, this is, I'm taking it as capital 2. So delta P value from the first pink color box, I'm going to substitute 2mv sine phi by 2 here. So delta P from what I'm going to write 1 and 2. That is 2mv sine phi by 2 is equals to 1 by 4 pi epsilon naught QQ by VB into 2 cos phi by 2. So if you cancel 2 and 2 over here, and that too, suppose if I want to calculate B, I take B onto the here left hand side, and I will get finally here. That implies I am coming to B is equals to finally 1 by 4 pi epsilon naught QQ by V. One more V will add here, and M also comes to the denominator. That is M V into V, that becomes V square into 2 already cancelled. Cos phi by 2 by, if you take sin phi by 2 the other hand, that becomes cot phi by 2. Okay, this is what we say the relation between impact parameter and the scattering angle, the relation. Okay, this is one relation. And later, actually, I'm interested to explain the relation between impact parameter and minimum separation also. Okay, now I'm going to deal with the relation between impact parameter and the minimum separation between alpha particle and the nucleus. Okay, this one I am going to highlight here. What is this relation? Okay, means indirectly, simple words, we can say I'm going to find out the relation between B and R minimum. Okay, so to get R minimum into this concept here, what I'm going to explain, again I go back here, instead of mr square into d theta by dt here, according to law of conservation of angular momentum, instead of this part mr square into d theta by dt, I use mv1 into R minimum in place of here. So directly I come to, according to law of conservation of, better I write LC, law of conservation of angular momentum. I write initial one is MVB is equals to, here finally I will write at minimum separation. Since V1 is perpendicular to R, I write MV1 into R minimum. That implies I'm getting a small relation here, cancel, V into B is equals to V1 into R minimum. Okay, if you want to substitute the B value here, you can substitute there to simplify. Okay, right. So you are going to use the this parrot color box also. Okay, suppose from there, if I substitute here in the next page, V into, that implies V into B, if I substitute 1 by 4 pi epsilon naught QQ by MV square into cot phi by 2 scattering angle. If I am not wrong, yes, correct. Cot phi by 2 is equals to, I am going to write V1 into R minimum. Okay, take it as one equation here. Okay, like one small equation. Okay, let it be the equation capital 3. Now here, if you see, I am finding out two unknowns. V1 I don't know, or minimum I require. I want to calculate that one. Okay. So here, what I have to do, I want to actually here use the law of conservation of energy. Okay. So law of conservation of energy, from there I can write like here I take using the law of conservation of energy. I write here. Initially, I consider the distance already. I told it is considered to be projected from infinite distance. Initial electrostatic potential energy is 0 and kinetic energy is half mv square. That I write here in this page. So initial potential energy is 0, kinetic energy is half mv square. Okay, we are neglecting the gravitational potential energy there. Why? Because they are small particles. And interaction potential energy also between alpha particle and nucleus. Okay, like a gmm by r, the minus gmm by r, neglecting that one compared to this electrostatic potential energy. Okay, that is very small. That's why we are neglecting the gravitational potential energy. Even by the earth also we are neglecting. So we are taking only electrostatic potential energy. That electrostatic potential energy at minimum separation is 1 by 4 pi epsilon naught q by r. R is r minimum. Plus kinetic energy is half mv1 square. Okay. This one you could take it as equation 4. Okay. This you take it as one box and take it as equation 4. Okay, whichever comfortable that you try to use. Here after substituting the b value over here, I am not comfortable to substitute, so better I go with here vb is equals to v1 into r minimum. So from vb is equals to v1 into r minimum, I will try to eliminate v1 here. Okay, that implies v1 is equals to, I will write here vb by r minimum. Okay, that I go to substitute there and I will get here half mv square, half m if I take common, v square minus v1 square is equals to 1 by 4 pi epsilon naught. I will get q by r minimum. Okay, this is from equation 3. Okay, this is what I wrote here. And then from this equation, if you highlight this box, v1 is equals to vb. Okay, from here, take it as like some small equation. This is like a 1, 2, 2 equations we took there. Take it as equation 3. From 3, I can write here like substituting here half m into, I'm going to write v square minus v1 square. I write v square b square by r minimum whole square, that is r minimum square. Okay, substituting v1 over here, that equals to, I'm going to get 1 by 4 pi epsilon naught q by r minimum. So if I take even half m into v square also common, I will get 1 minus some b square by here r minimum whole square, that is square, is equals to 1 by 4 pi epsilon naught into q into, I write it as 1 by r minimum. Why I'm writing like this? I have to eliminate many things now. I require the relation between b and r minimum. So all these things are unnecessary things here in this equation. So here to incorporate b over here to substitute, better I go with again, instead of the third equation, I go to this equation, what I got, final result. Okay, from the equation b is equals to what I got, 1 by 4 pi epsilon naught q by mv square into here cot phi by 2. So in place of 1 by 4 pi epsilon into QQ, I take it as B into mv square into cot phi by 2 taken to the other hand, that becomes tan phi by 2. Okay, is equals to 1 by 4 pi epsilon naught into QQ. This one I am going to substitute there. Okay, so simple, take it as equation 4 and take it as equation 5 from these two. What I am going to write in place of here, by taking the left hand side as usual of mv square into 1 minus b square by r minimum square. Okay, if possible, I take here the LCM straight away. So better I take LCM, that is r minimum square minus b square by r minimum square is equals to, I write b into mv square into tan phi by 2 into 1 by r minimum. Okay. Here I will get mv square get cancelled. Okay. And here I will get this 2. Take to the other hand, I will get this is 2b 1 r minimum get cancelled here. So left hand side I'm getting r minimum square minus b square by r minimum. 2 already taken there, 2b, mv square already cancelled there, and r 1 r minimum already cancelled there, that is r minimum into tan phi by 2 I'm getting. So if you take cross multiply and rearrange, you will get one quadratic equation for r minimum, Nana. So you will get here r minimum square minus b square equals to what you got there, 2b into tan phi by 2 into, if you take cross multiplication, r minimum over here. This is like one quadratic equation, that is r minimum square minus r minimum into 2b tan phi by 2 minus here b square equals to 0. This is the quadratic equation what you got. Okay. It is appear like the ax square plus bx plus c. Okay. So to find out the roots of that x means r minimum, here we use minus b, minus b is minus of 2b sin tan phi by 2 minus b plus or minus root of b square. B square means minus 2b tan phi by 2 whole square minus 4a. A is 1 here, 4a. C is minus b square whole divided by, you are getting 2a. A is 1. So this is all together, you are getting 2b tan phi by 2 plus or minus. If you take 4b square here and 4b square over there out, that will become 2b into root of, you will get here tan square phi by 2 minus of minus, that becomes plus 1. Sorry, this is minus 1. Sorry, minus of minus plus 1. Plus 1 divided by 2. So by cancelling the 2 there, you will get b tan phi by 2 plus or minus, that is b. 1 plus tan square theta is secant square theta. Okay, that if you write here secant square phi by 2, okay, that you will get here by taking b common. Tan phi by 2, you can write it as sin phi by 2 by cos phi by 2. Plus or minus, you will get root of secant square is secant. Secant is 1 by cos phi by 2, you will get. So here I think you understood. You are getting R minimum almost coming to the last part. So I change that color here. I take yeah, here R minimum I am getting, that implies B into, you are getting B into sine phi by 2 plus or minus 1 divided by here cos phi by 2. Here, if you see that scattering angle is not 180 degrees. Okay, that's already I told. 180 degrees means you have to project along this red line. Then only it will turn back. Okay, not 180 degrees means phi is less than 180. Their scattering angle. Okay, so here phi is less than 180 degrees means phi by 2 is less than 90 degrees. Less than 90 degrees means sine phi by 2 is surely less than sine 90. So sine phi by 2 is surely less than 1. If it is less than 1, then here if you substitute the value which is less than 1 and take minus 1 out of plus or minus, you will get a negative value. Getting negative value is wrong actually. Distance we should not say in negative terms. That's why negative is here finally eliminated, and we are taking only plus there. That implies R minimum I am taking here B into sine phi by 2 plus 1 by cos phi by 2. This is the final formula. Okay, you can leave it like this, and you can rationalize also. Means here multiplying with 1 minus sine phi by 2 by 1 minus sine phi by 2. If you multiply with 1 minus sine phi by 2 by 1 minus sine phi by 2, you will get 1 minus sine square phi by 2 at the numerator. 1 minus sine square phi by 2 is cos square phi by 2. Cos square phi by 2 means 1 cos phi by 2. If you cancel, you will get another one. R minimum is equals to B cos phi by 2 by rationalize actually with 1 minus sine phi by 2. Okay, I should not take sine phi by 2 minus 1. Why? Because already I explained here sine phi by 2 is less than 1. So 1 minus sine phi by 2. Okay, this is also the another answer. Anyone you can take, both are correct, Nana. Here, either you take, better I take another color. It is not highlighting more. Yeah, this is better. Okay, this is the relation between minimum distance and impact parameter, and here we got the scattering angle. Okay, this is the story, Nana, the relation between those two. Here impact parameter and scattering angle, and also the impact parameter and minimum separation. Okay, if you like my video, don't forget in sharing and liking my video. Thank you everyone.